JMath.
This is the video where we're going to practice those triangle sums. So the ones where you actually get a fraction, and the other ones where you get variables and you must leave everything in terms of those variables. So let's do a few sums. You can see which ones we're going to discuss in this video. Please pause now, try all of them, and then let's mark it together at the end. And hopefully you learned something, or you got 100%. Let's see what's going to happen. So question 1, I can see there's a cos A and a sine B. Whenever I see that, I know I'm going to have to do two separate triangles with this one. So let's first just set up those ones. I'm going to do everything with A. I'm going to do in orange and everything with B in purple. So first thing I have to do is I need to get cos A alone. So cos A is going to equal minus 4 over 5. Now, the info they give me tell me that cos needs to be negative. Okay, so cos is negative in 2 and 3, and sine needs to be positive, which is 1 and 2. So that means I'm going to work in quadrant 2. The one I tick twice is always the one I'm going to work in. So I'm going to draw my triangle, okay, away from the cross and then back to the x-axis. Remember, you always want one of the triangles of a bow tie in this. Okay, so now I know it's cos. So cos is adjacent over hypotenuse, and I just need to do Pythagoras. So I'm looking for the opposite side, which we also call y. So y squared is equal to 5 squared minus 4 squared. And that is just going to give me y is the square root of 25 minus 16. So y is equal to plus or minus 3. In this specific sketch, the 3 is going up, so it's a positive direction. Okay, great. Some teachers subtract a mark if you don't write pith there. Now I can go over to the B triangle, and first thing I'm going to do is I'm going to get sine B alone. That's going to be minus 12 over 13. And then if I see the info they give me, I can mark where sine is negative. So sine is negative in 3 and 4. And then tan is positive in 1 and 3. So the triangle I'm going to draw is going to be in the third quadrant. I hope this is making sense, guys. It's a very important skill. Otherwise, everything's going to be wrong. Okay, so sine is opposite over hypotenuse. I just need to do Pythagoras. So x squared is equal to 13 squared minus 12 squared. That's going to be 169 minus 144, which is just going to give me plus or minus 5. In this case, we're going to the left, so it's definitely a minus 5. Very important. This is the B triangle, and this is the A triangle. Okay, so finally, my setup is done. Now I can start with the actual question. So question 1 says, what is cos A plus B? So compound angles, I can just use my formula and expand first thing with this. So it's going to be cos A, cos B, and then it has a plus in the bracket, but with cos, it always changes to a minus. So minus sine A, sine B. So now I just need to check where's my A triangle and my B triangle. So if I first look at the A's, cos A is going to be minus 4 over 5, and then sine A is going to be 3 over 5. Then if I go to B, it's going to be cos, so therefore it's minus 5 over 13, and then sine is going to be minus 12 over 13. So now I know I'm multiplying this, I'm minusing this, and I'm multiplying that. So then I can just multiply and then check all the pluses and minuses. So this one would be positive 20 over 65. The next one, there is a minus, but there's a minus 12 as well. So that becomes a plus, and then 36 over 65. And therefore the answer is 56 over 65. I just leave it like that. Please don't go decimals, just leave it like that. So with question 2, it's with the orange triangle, and it says cos 2a. So my triangle is just a single a, so therefore I'm going to have to use a double angle formula. So I'm just going to go for the cos one and say this is 2 cos squared a minus 1, and therefore I can change it to 2. I know cos is minus 4 over 5 squared minus 1, and that I can just type in my calculator, and I'll see this is 32 over 25 minus 1. So the final answer is just going to be 7 over 25. So with question 3, they're trying to just trick me a bit. Once again, my triangle is for a single B. The question is for a double angle B. But because it's tan, I don't know the double angle for tan. There is one at university level, but it's very complicated. So I'm just going to change this to sine 2B over cos 2B. I know sine 2B is just going to be 2 sine B cos B. And then with cos 2B, I am just going to go with the sine one, because that's what the purple triangle is all about. So I'm just going to say this is all over 1 minus 2 sine squared b. Okay, so let's just go and sub in. So sine is minus 12 over 13. I'm going to put that in a bracket. And then cos is minus 5 over 13. All of that is over 1 minus 2. And then we said sine was minus 12 over 13. And that is squared. You can just type in this whole thing in the calculator and it will tell you it's minus 120 over 119. Okay, That is a pretty big and messy screen, but let's see where you would get your marks. So you would get 4 marks for question 1 if both of your triangles are correct. Then if you expanded and subbed in the correct compound formula and then got the answer, 4 marks. Question 2 would just be 2 marks, 1 for the expansion and 1 for the final answer. And then question 3 would be 5 marks. So for doing sine over cos correctly, for then getting the correct double angles, then for subbing in, and then for your final mark. So 5 marks for that question. Hey, question 2, I'm straight away just going to start by choosing the correct quadrant. So I can see tan is negative and sine is positive. So tan is negative in quadrant 2, quadrant 4. Sine is positive in quadrant 2 and quadrant 1. So therefore, I'm straight away going to go for quadrant 2. Draw my triangle there, away from the cross, always back to the x-axis. Great. Now what's extremely important is this is a 2 theta triangle. And I know tan is opposite over adjacent, so that is going to be the root 5, and that's going to be the 2. Now, many people get stuck in the minus is now next to the root 5. But remember, a minus divided by a plus stays a minus. What that means is the minus can move up and down in the fraction. Just put it at the place where it is correct according to the Cartesian plane. So, sorry for the big words. That just means x is negative in this picture because it's going left, but y is positive. So I don't want the minus at something that is positive. Now I'm just going to Pythagoras, and I'm going to say, okay, so hypotenuse squared is equal to square root 5 squared plus negative 2 squared. That gives me 5 plus 4, and it is the square root of that, so that is just 3. It's the hypotenuse, so it never gets a minus. And now my triangle is complete. I can now go for the questions. Question 1, cos of 2 theta, so extremely easy. They give me the 2 theta triangle, so I literally just need to say adjacent over hypotenuse. Okay, question 2. So now I need to think a bit, because the triangle is a double angle, but the question is a single angle. Now I can't just half things and sub it in. So what I'm going to go for is, this looks very familiar. It almost looks like the sine double angle. So I'm actually going to start with sine 2 theta, according to this triangle, is going to be opposite over hypotenuse. But I can then expand the sine double angle. So 2 sine theta cos theta must be equal to root 5 over 3. And therefore, to answer their question, I can shuffle things around just to humor them and write it in the same format. So cos theta sine theta is then equal to root 5 over 6, because I'm dividing both sides by 2. So question 3, to get to sine theta from a double angle triangle, I always need to go through the cos double angle formula. So first thing I'm going to do there is I'm going to say cos 2 theta is equal to minus 2 over 3. So I'm starting with my answer for question 1. Now I'm going to choose the option that has a sine in it. So 1 minus 2 sine squared theta is equal to minus 2 over 3. So I'm going to subtract the 1 on the other side, and therefore this is going to be minus 5 over 3. Now I'm going to divide it by negative 2 on both sides. So sine squared theta is equal to 5 over 6, and therefore sine theta is equal to the square root of 5 over 6. So once you get used to it, this question isn't very difficult, but I can promise you a lot of people lose their marks because they just go in half the triangles. You are not allowed to do that. That is illegal if you want to get full marks. So you would get 3 marks for question 1, 1 for the triangle, 1 for Pythagoras and all the sides being correct, and then 1 for actually getting the answer. Question 2 would be 3 marks for knowing its sine double angle, then for expanding it correct and getting the right answer. Question 3 would also be 3 marks for going to the correct sine double, then for doing your simplification correct, and then writing the right answer. So now we get to the other type of sums where they don't give you so much info, but they ask you complicated questions. So I don't even need to wonder in which quadrant this is. It's always in quadrant 1 because it's 21 degrees. Below 90, so I can just go for first quadrant. So I'm going to put a 21 there. I'm going to put a 90 there. Then this is tan. So tan is opposite over adjacent. So I'm just going to put a 1 there. And then I can Pythagoras. So hypotenuse squared is equal to 1 squared plus p squared. That's equal to the square root of, remember, 1 squared is just 1. And p squared needs to stay like that. The root can't cancel the square. So I'm going to complete my triangle, and it will look like that. Now I can answer the question. So question 1. So I'm just going to look on the Cartesian plane. So the cos diagram. So this is going to be in the 4th quadrant. So I can just say it's tan 360 minus 21. 4th quadrant, so tan is negative there, minus tan 21. And I know tan 21 is p, so this answer is just minus p. Question 2. So sine 201, that's the 3rd quadrant. So it's sine 180 plus 21. Sine is negative there, so minus sine 21, and sine is opposite over hypotenuse. So from the 21 side, I can see opposite is p, and hypotenuse is square root of 1 plus p squared. Question 3, cos of a negative. Remember, cos just eats the minus, so the minus just goes away, and that's just cos 21. And then if I look at the triangle, it's adjacent over hypotenuse, so 1 over 1 plus p squared in a root. So question 4, sine 48. So now I need to figure out, how does 48 relate to 21? It really doesn't. So it's not half, it's not double, it's not a compound. So if I add 21 to it, I'm not going to get to 60. But I can see if I add 42, I'm going to get a 90. So if I use cofunctions, I can say, okay, but if this is sine 90 minus 42, I can rewrite this as cos 42. And that is double 21. So then I'm just going to say this is 2 cos squared 21 minus 1. And then I can use the triangle to sub in. Cos is adjacent over hypotenuse, so 1 over square root 1 plus p squared, all squared minus 1. So if I were to simplify that, I'm just going to square the top. So 1 times 1 is just 1, and I'm going to multiply the 2 in. So this answer would be 2 over 1 plus p squared minus 1. And then because it's a fraction, I can then LCD, and this would be 1 plus p squared, and that would just change to 2 minus bracket 1 plus p squared. And then the final answer there would be 2 minus 1. So it would be 1 minus p squared all over 1 plus p squared. Weird answer, but that is what it should be. So question 5, I now once again need to figure out how does this relate to a 21. If I do the quadrants, it's going to be 180 minus 48. Okay, and we saw 48 as cofunctions with 42. Or I can say this is immediately cofunctions, and I can rewrite this as cos 90 plus 42. Now remember, this is the only one that turns into a negative, so this is minus sine 42, which means it's minus 2 sine 21 cos 21. Now I can use the triangle and just say this is minus 2 times p over root 1 plus p squared, and then times 1 over root 1 plus p squared. If I then just multiply all of that, my final answer would be minus 2p over 1 plus p squared. So question 6 is the one that many people struggle to get that to a 21. Okay, once again, it's not double, it's not half, but this time, if I add 21 to 39, it's going to give me a 60. So remember, if you're stuck and you tried everything, just take the degree they give you, the 21, and subtract it from the question. 39 minus 21 is not something special, but if I plus 21, I get a 60. So then I know I'm going to rewrite cos 39 as cos of 60 minus 21. Now I can use the compound angles and just expand this. So this would be cos 60 cos 21 plus sine 60 sine 21. I can then just use my special angles and the triangle to say this is going to be a half times adjacent over hypotenuse, and then this would be root 3 over 2 times opposite over hypotenuse. So 1 plus p squared. Final answer to this question would then be 1 plus root 3p over 2 root 1 plus p squared. Not a nice answer, but that is what they want. Okay, guys, so I know this is complicated and it seems very, very tricky, but just always try to get it back to 21 and then use your formulas. Let's mark. Question 1 would be 3 marks, 1 for the triangle and Pythagoras, and then a mark for reduction and a mark for your answer. Question 2 and 3 are both 2 marks, 1 for your reduction and 1 for subbing incorrectly, so 2 marks each. Question 4 would be 4 marks, so for the cofunction, then for the double angle, for subbing into the double angle, and then simplifying your answer correctly. Question 5, exactly the same thing, also 4 marks. So a mark for doing the cofunction, for the double angle, subbing into the double angle, and then simplifying. Question 6 can be 5 marks, a mark for spotting the compound angle, then for expanding it correctly, 2 marks for subbing incorrectly because there's special angles and the triangle, and then a mark for your simplification. So 5 marks for that one. So let's do question 4. So I know it's cos 25. I can immediately draw a triangle in the first quadrant. So I would just go there, put a 25 there, and then this is adjacent over hypotenuse. So if this is adjacent, then that is hypotenuse. If I then do Pythagoras, I can say y squared is equal to 1 squared minus m squared, meaning y would then just be the square root of 1 minus m squared. I can just put it there. So if the question is sine 25, I have a triangle for 25 degrees, so therefore I can just say it's opposite over hypotenuse. So sine 25 would just equal 1 minus m squared. It's over 1, but you don't need to write that. Question 2, so now it is cos 50. I know 50 is double 25, so if I expand this, I would say, okay, so this is cos 2 times 25, and I can then go for any of the 3 formulas. Try and choose the one that won't give you a horrible square root, so that would be only coses. So I'm going to rewrite this as 2 cos squared 25 minus 1, and that would then just be 2m squared minus 1. Question 3, so now I'm back to how do I get a 55 from a 25? I can't take it to 90, that's going to be 35, so I need to think of something else. So it's not double, it's not half, so remember my tip, try and add or subtract the angle of the triangle, so 25. If I add 25, I'm going to get to 80, it's not what I want, but if I subtract 25, I'm going to get 30. So I'm going to go for that one, so I'm going to say it's cos 30 plus 25. Remember, my answer to the bracket must be 55 again. So if I expand this, cos 30, cos 25, because it's cos, it changes to a minus, so sine 30, sine 25. Cos 30 is just root 3 over 2. I know cos 25, according to this triangle, is just m, minus a half, and then the square root of 1 minus m squared. So for the final answer, I can just do LCD. That would be a 2, and then it's root 3m minus the square root of 1 minus m squared. That's it. That's what they want. So question 1 would be 2 marks, mark for the triangle Pythagoras, and then your answer. Question 2, also 2 marks, mark for expanding the double angle correctly, and then subbing in. And then question 3 would be the compound angle, then subbing in correctly twice, and then for your final answer, simplification. Question 5. So once again, I am going to draw a triangle. It's 10 degrees, so it's just going to be in the first quadrant. Because it is cos, I know cos is adjacent over hypotenuse, so that's a p, that's a 1. I hope by now you get the pattern of what this side is going to be, just hypotenuse squared minus adjacent squared. But I have to write the Pythagoras for my teacher, so it's going to be 1 squared minus p squared. Must write that I'm doing Pythagoras. And then y is going to equal square root of 1 minus b squared. So now my triangle is complete. I can go and check how would I get the answers. So cos 85, I now need to rewrite as something with a 10. 85 is going to be very difficult to get down to a 10, but I know that that is going to be cofunctions with sine 5. So I'm actually going to work with sine 5 in this case. So if I go and I write, okay, I know cos 10 is equal to p, I can say, okay, but cos 10 is actually the same as 2 times 5. And now I can just choose the cos option that has only a sine in it. So I'm going to say it's 1 minus 2 sine squared 5 is equal to p. And now I just algebra until sine 5 is alone. So I'm going to take over the 1. Now I'm going to divide by negative 2, so sine squared 5 is equal to p minus 1 over negative 2, and then I'm just going to square root this whole thing, and that would be the answer. Okay, so in question 2, if I work with tan 5, I don't have a double angle for tan, so I'm going to have to rewrite this. Tan 5 is equal to sine 5 over cos 5. Now we already saw that sine 5 was equal to the square root of p minus 1 over negative 2. So now we just need to work out what cos 5 would be. So I'm going to work through the cos double angle again and say, okay, so if cos 10 equals p, then 2 cos squared 5 minus 1 must also equal to p. So I'm just going for the double angle that does not have sine in it. So now I'm just going to move the 1 over and divide by 2. So then I can say, okay, so cos squared 5 would be equal to p plus 1 over 2. And therefore, cos 5 is equal to the square root of p plus 1 over 2. Now I have a value for sine 5, and I have a value for cos 5. Now I can say, okay, so I know tan 5 would then be equal to sine 5 over cos 5. And in this case, it's going to be the square root of p minus 1 over minus 2 divided by the square root of p plus 1 over 2. Okay, so if I write it like that, the minus 2 is now bugging me. So I am actually going to split the square roots. Remember your exponent rules from grade 9. If I'm square rooting a fraction, I can separately square root the top and the bottom. But before I do that, I want to move that minus to the top. So I'm going to say this is minus p minus 1. The reason I'm doing that is I want this to just be a square root 2. Now I'm going to say I'm going to divide that by square root p plus 1 over square root 2. I hope you can see where I'm going with this, because now I am going to tip and times. So I can multiply that minus in, or I can just do a sign change to just make it look a bit better. Square root 2 multiply by square root 2 over square root p plus 1. Now the square root 2's can cancel, and the final answer to this question is just square root of 1 minus p over square root of p plus 1. Let's mark. Question 1 would be 4 marks, so mark for the triangle and Pythagoras, then for spotting the cofunctions, for using the correct double angle, and then for simplifying correctly. Question 2, you'd get a mark for changing tan correctly, then for subbing in sine and cos correctly and simplifying. So that was quite complicated. How did this video go? Do you understand these things, and would you get your full marks in an exam? Please let me know.
If this video helped you, please like and subscribe.
JMath.